Oh, here we go, ladies and gentlemen. We are talking about polygons in this unit. We've been talking all about triangles, and so we're moving on and up in the world to polygons. We want to be able to find the sum of the interior angles of any polygon today, among other things. A polygon is a closed figure formed by three or more line segments called sides. So a polygon literally translates to many sides. It is a many-sided figure from triangle on up, and the sum of the measures of the interior angles of any polygon can be determined by the number of triangles that can be drawn within the polygon. And so this is talked about a lot. And again, it's one thing that I absolutely love is to not have to memorize things. And this is one of those things that is actually really, really easy to figure out. So we already know that a triangle has three sides. It is one triangle, and how many degrees do the angles? They add up to 180 degrees. Now, we can continue thinking about how many triangles there are. So if I have a quadrilateral, I can pick one vertex here, one corner, and connect the diagonal. And now we have four sides. How many triangles do we create? Two. And each triangle we know has 180 degrees. So how many degrees is a quadrilateral going to have? 360, because it's 180 times 2. 360 degrees. Now here we have a pentagon. A pentagon is a five-sided polygon. And again, we can pick a single vertex and draw diagonals. This is a common test question, ladies and gentlemen. How many diagonals can you draw from one corner of a polygon? This is exactly what they're talking about. And so, again, we can draw a diagonal, which would create how many triangles do you see there? 3 triangles. And so then if each one is 180 degrees, well, how many? Yeah. 540, which would be 180 times 3. A hexagon is how many sides? 6 sides. And look at that. How many triangles can we form? 4. And then how many degrees is it going to have? 720. How'd you get 720? Timesing it by 4? Yeah, 180 times 4 is 720 degrees, sure. What's a heptagon? 7-sided, yep. Heptagon, how many triangles would we be able to draw in a heptagon? How'd you figure 5? There's definitely a pattern. Yes, there is. All right, and so how do we figure out the sum of the interior angles? Yeah, 180 times 5. Very good. And that's going to be 900. Good. Octagon has how many sides? 8, which means that's going to have how many triangles? 6 triangles. And then to get the number of degrees, it's going to be 1,080. Yeah, 1,080. Again, that's 180 times 6, so just adding another 180 to that. Nonagon. What's a nonagon? 9-sided. Yep, 9-sided. How many triangles is that going to have? 7. And then we would do 180 times 7 to get the number of degrees. Yeah, 1,260 degrees. What's a decagon? 10-sided figure, which means there's going to be how many triangles? 8 triangles, good. And so we can do 180 times 8, which would be, oopsie daisy, Yeah, 1,440 degrees, 1440. Another one that comes up is a dodecagon. Dodecagon, like doe, a deer, dodecagon. What do you suppose that one is?
20.
It's actually 12. 12 sides. So in case that comes up, a dodecagon has 12 sides. It's like 2 plus 10 is what that really says. Dodec. So 2 and 10. So that has 12 sides. So if that comes up, you'll know exactly what that is. So obviously there's a pattern, and that's what's so fun about math, is how many things actually just have patterns like this, which are super easy to see. Well, if we're going down, what if I wanted to have, like, I don't know, not 10 sides, not 12 sides, not 20 sides, but what if that pattern continued? And I watched a video this weekend where they did 2 to the 92nd number of sides on a polygon. 2 to the 92. That's 2 times 2 times 2 times 2, 92 sides. That is a whole lot of sides. So that is, there are a huge number of sides there. And instead of giving it a number, I'm just going to call it n, like n sides. So if there were n sides, how many triangles would we be able to draw? Almost. It's, so how do we get 8? We would take the number of sides and subtract 2. So we were going to take our number of sides n and subtract 2. So n minus 2. Yeah, all we want to do is take n minus 2. And then to figure out the number of degrees, all I had to do was multiply the number of triangles times 180. So the sum of the interior angles of a triangle, or of a polygon, can be found by 180 times n minus 2. 180 is how many degrees in a triangle, and n minus 2 is the number of triangles that are formed. Where n is the number of sides of a polygon. So this is the formula we can use to find the number of degrees in any polygon we want. So find the sum of the measures of the interior angles of a 15-gon. A 15-gon. We don't have a special name for that. We just call it a 15-gon. All right. So if n is 15, I want to find the sum of the measures of the interior angles, then S equals 180 times 15 minus 2. And I can just plug that into my calculator. 180 times 15 minus 2, which is just 13. You could just use 13 if you wanted to. And we get 2340 degrees. 2340 degrees. What should I do for a 36-gon? Good. Times the quantity 36 sides minus 2 creates our triangles. So 180 times, I'm just going to type in 34 because that's easier. So 6120 degrees. Fantastic. All right. Now, over here. So this is the sort of reverse of the question. This is asking how many sides. What are they asking us to find if they're asking how many sides? It's asking us to figure out n. All right. If it's asking how many sides, it says find n if the sum is 3420. So where do I put the 3420? Yeah, the sum is 3420. So we're going to use this 3420 in place of the s equals 180 times n minus 2. Can we solve that equation? Yeah, what would you like to do first? We can distribute the 180. I also heard divide. Raise your hand if you would like to divide the 180. Raise your hand if you want to distribute the 180. Oh, I think the dividers have it. Either way, you're going to get the same answer, all right? But dividing is absolutely going to be a little bit easier. So we're going to divide both sides by 180. And those zeros are going to cross off. So 342 divided by 18 is 19. So you get 19 equals, the only thing left on the right-hand side is n minus 2. How do we get n by itself? Add 2. So we get n equals 21. And that'd be 21 sides. So this is a 21-gon. All right, so we have this. Yeah, and then add the 2. This is how we can use this sum formula. And again, is it something you need to memorize? It's pretty easy to figure out once you could do this same pattern anytime you wanted to. And that's kind of like my favorite thing, is when we can just really easily figure something out by recognizing patterns. So that's kind of a nice thing. All right, so turn the page. Whoops. Just kidding. All right. Here we have regular polygons. We're going to talk about regular polygons. So we were talking about general polygons that just have a number of sides, any sides we want, any amount of sides we want. But regular polygons are polygons in which all sides are congruent. All the side lengths are congruent. Therefore, if all the side lengths are congruent, what should we know about all the angles? They're also congruent. Therefore, the angles are also congruent. So when we talk about regular polygon, regular isn't like Joe Schmo. Regular means super, super specific, okay? So a square is a regular polygon because all 4 sides are congruent and all 4 angles are congruent. So it's called a regular quadrilateral. And so a regular polygon means all the sides are the same and all of the angles are the same as well. And so if we want to find the measure of a single interior angle in a regular polygon, not the sum, not all of them added up, but what if we want the single measure, one angle measure? All we have to do is divide the sum of the interior measures by the number of sides. So let's see. For instance, that's saying, hey, what was our formula for the sum of the interior angles? 180 times n minus 2. And then if I want to know, that gives me all the angles, and I want to know each one, I just have to divide by n, the number of sides there are. So find the measure of each interior. This is the reading that you have to be very careful of today. Each interior angle. A regular pentagon. So that's important. We know it's a regular pentagon. How many sides does a pentagon have? 5. N equals 5. So we're going to figure out the measure of each interior angle, we're going to do 180 times 5 minus 2 and divide that by 5. So 180 times 3 gives me 540. 540 degrees divided by 5 angles, so split amongst 5 angles, we get 108 degrees. Oops, 108 degrees for every single angle. Will you go ahead and do the 18 gon? Use your calculator and figure out the 18 gon, number 6. All right. Hopefully you got 160 degrees. Anyone not get 160 degrees? Okay. Over here, 6B. Again, I got to flip this question around. It's asking how many sides. What's it asking for if it's asking how many sides? What are we trying to figure out? Yeah, it says find n. So we need to solve for n if each angle of a regular polygon is 162 degrees. What do you suppose we need to do? Good. So they're telling me each regular angle. So this is our 180 times n minus 2 divided by n. So each interior angle, we're going to take this formula and set it equal to 162. N minus 2 over n equals 162. Now on this one, how are we going to solve for n? Yeah, we can. Multiply by n, yes. I do need to get that n out of the denominator, so I'm going to multiply it to the other side. So 162n equals, and I think I will go ahead and distribute, so you don't have to, but you can. I'm going to distribute that at 180, so I get 180n minus 180 times 2, which is 360. Now what do you want to do? Minus 180n, minus 180n. Move the n's so they're on the same side. All right, let's see. 162 minus 180. I don't know math today. So negative 18n equals negative 360. And then, yep, divide by negative 18. So we get n equals 20 sides. All right, so we want to be able to use these formulas forwards and backwards. Finding the individual angle or finding the number of sides. So making sure you're reading carefully. This becomes very tricky when you do delta math later on. So make sure you're reading very carefully. All right, so let's talk. That was all interior angles, total interior angles or individual interior angles. Now, exterior angles. Exterior angles are supplementary to their adjacent interior angles. So you can see we have this lovely picture of a triangle here. And what we've done is extended one side out on each. And what that creates are these little exterior angles. So if my interior angle is 179, what's this exterior piece right here?
180
minus 79, yeah, 180 minus 79 is, 101. I could have done that math, I think. All right, and if one side of my angle is 40 degrees, what's the other side? 140. Yeah, 140 degrees for this other exterior angle. And if one side of my angle is 61, 180 minus 61 gives me 119. Interesting. What is the sum of those exterior angles? So if each angle has one exterior angle, I want to sum them up, add them up. So 101 plus 140 plus 119, and I get 360. Interesting. Ladies and gentlemen, I want you guys to sum up those exterior angles on the quadrilateral. You guys here, you're going to sum up the angles on the pentagon. So, and then last, you guys, sum up those exterior angles on the hexagon. All right, add up those exterior angles. Figure out the exterior angles and add them up. Giving you 1 minute. Find those exterior angles and add them up. What was your sum? Okay. You guys over here, what was the sum of the quadrilateral exterior angles? 360. Hey, look at that. All right, you guys in the middle, what was the sum for the exterior angles of the pentagon? 360. Hey, you guys over there, what was the sum for a hexagon? 300. Do you think that's crazy or a pattern?
It's a pattern.
Holy moly, it's a pattern. Always. What can we conclude about the sum of exterior angles of any polygon? Always the sum of the exterior angles, right here, the sum of the exterior angles is always 360 degrees. What's the sum of the exterior angles if there's 1,000 sides? 360 degrees, every single time. It doesn't matter how many sides we have, they're always going to be 360 degrees. So what is the measure of each exterior angle of a regular hexagon? This is a different question. What is the measure of each exterior angle? The individual exterior angle. Not the sum, but the individual. How do we figure out what the exterior angle of a hexagon is? Yes, so we can take our exterior angle is 360, but a hexagon has 6 sides, which means it's got 6 congruent angles, and 360 divided by 6 is 60 degrees. So each exterior angle is 60 degrees. What is the measure of each exterior angle of a regular 24gon? Each exterior angle, what do we need to do?
No, that makes no sense.
360 divided by 24 sides. Exterior angles was 360 divided by 24, we get 15 degrees. All right, turn it around. If the exterior angle of a regular polygon, the exterior angle of a regular polygon is 12 degrees, how many sides does it have? What can we do for that? Yes, 360 divided by n, and that's equal to 12 degrees. The exterior angle, each exterior angle was 12 degrees. How are we going to solve this one? Times by n to the other side, good. So 12n equals 360, and then divide by 12. Divide by 12. So n equals, what is that, 30? 30 sides. Okay. Do you guys have any questions for me?
No, man. It's a paper.
It is a paper.